Hey guys, this is Coach Lowe and this is Geometry. We are in Chapter 7, Section 6, Similarity Transformation. So let's get some terminology out of the way to start with. We actually talked about this a little bit. Dilation. A dilation means that we are enlarging something, making something larger, or making something smaller. And so we talked about this when we did translations like slides, rotations, reflections. We had a little foldable that we put in our notebooks, and dilation was on there. And it this deals with a scale factor. So it kind of goes right into play with our triangles that we've been looking at. So a dilation is going to enlarge or reduce the original figure. And it's going to do so proportionally. Now, when we look at this, we have a center of dilation. Usually it's 0, 0. We also have a scale factor, and that scale factor tells us how large or how small our new image is going to be. So scale factor is going to tell us how large or how small our new image will be. And to find that scale factor, we can take a side of the image, so the new shape or the new size, and divide it by a side of the pre-image, which was the original figure. So remember, this is original. All right, so this would be dealing with side lengths. All right, so this scale factor, we are going to have an enlargement. So we'll have a bigger figure if the scale factor is bigger than 1. So a number larger than 1 gives us an enlargement. A shrink or a reduction, so to shrink the figure, we need a number that's between, a scale factor that's between 0 and 1. Remember, the negative is just going to flip it over. So the scale factor is going to be between 0 and 1 if we want to write it as an inequality. Between 0 and 1, which means it would be a decimal number smaller than 1. The reason why I say that is because like 2.5 is a decimal number, but it's bigger than 1, so that would be an enlargement. It would be 2.5 times the size. All right, so let's look at a few problems. All right, I have two figures here. The black figure is the pre-image. That's the original. The red is the new figure. All right, so that's the image. So first of all, let's figure out if these guys are similar. So we need some side links here. I think we could just count these boxes, can't we? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so it's a square, 5 by 5. All right, so if this is a square, we're in good shape. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I have a square that's a 5 by 5, and I have a square that's a 4 by 4. We can find the slopes of these to look at the angles. This slope is 0, this slope is undefined, which makes this a right angle. Slope of 0, slope undefined makes that a right angle. So angles are congruent. I didn't put that on the page before, but you might go back to your notes and say, angles are congruent, sides are proportional, just as a reminder. Now, we started out this talk and we said similarity transformations, which tells us the figures are similar. So sides are proportional, angles are congruent. All right, so let's check this out now. Scale factor. So yes, these are similar figures. Yes, they are proportional to each other. We have a dilation. What is the scale factor? So we're going to do the image, a side of the image over a corresponding side on the pre-image. All right, so image is red, 4, pre-image, corresponding side, 5. So scale factor is 4/5. The red figure is 4/5 the size of the blue figure. So is it smaller? Yes, this is 0.8 as a decimal, but we also know 4/5 is less than 1. So yes, we have a reduction. All right, let's look at this next one. The black triangle is the pre-image, red is the image. We need side lengths. All right, so we see this one is 3. This one is 6. How do I find the lengths of these sides? What if I need those side lengths? Well, I do Pythagorean theorem, right? And I'm going to go ahead and walk through this because some of the problems that they give you, they're just going to give you ordered pairs, and you're going to have to plot them, and you're going to have to find the side lengths. So on example number 2, let's go ahead and do this. So this point, 1, 2, 3, 4, this would be -4, 1, 1, 2, it looks like 2.5, 1, 2, 3, 4. All right, so from here, we could do change in y over change in x, square those, right? So I have, excuse me, I'll do change in x first. So I'm going to do change in x, and I'm going to square it, and that gives me the change in this distance right here, which would be 1.5. And then I'm going to find the change in my y's and square it. And so how high did I go up? There's 3 different here. So I have the square root of 1.5 squared plus 3 squared. And that gives me the change here. I can compare that with the change here. The proportion of these two, so when I find this length and I find that length and divide them, should be the same as 3 over 6. Right, so I should get exactly the same ratio as I do with those sides. Thankfully, they told me these two figures were similar already, and I was just supposed to tell what the dilation was in the scale factor. So great and wonderful. Bonus for us because we don't have to walk through this, but just wanted you to see how to walk through that. So this would be on the pre-image, and then I would have to go do the same thing for the image. I would have to find this ordered pair and this ordered pair, which this one's nice, 0, 2, and go through the distance formula again, just like I did here, and then I would compare these two numbers. So I would do the distance formula for the image as well. We will be doing that probably as soon as you walk into class. All right, so again, when we are looking at similar figures, they're going to either tell you that the figures are similar, and they're going to have you find the scale factor, talk about the dilation, whether it's a reduction or an enlargement. By the way, this, I just wrote this backwards. Let's talk about the scale factor here. So scale factor for this one, image over pre-image. Sorry, I got a little ahead of myself here. All right, so working with this side, the image is 6. The pre-image was 3, so my new figure is twice as large as the original. So be careful on that. Don't just start throwing numbers down like I did originally. Talking and writing sometimes gets me. But this new red figure is twice the size. I better get twice the size when I find this distance formula as I work with this second image. All right, so they will ask you to do things like that, or they may ask you to verify that the dilation is a similarity transformation. There are several different things that they can do on that. And so we'll just look at the proportions of the sides and find the scale factor, and we're good to go. All right, so remember, distance formula, something that you're going to need as you walk into class the next time I see you. You're going to need this formula to be able to find the lengths of those legs of the figure that you're given. All right, so would you go back and would you put a little heart next to the scale factor, how to find the scale factor? All right, so that would be on your notes on your first page where we said scale factor tells us how much larger or smaller. And then we said scale factor was the image divided by the pre-image. Go put a heart by that on your notes page and then show it to me when you walk in. All right, guys, nice job today. This is Coach Lowe, and I'm out.